Alright guys, so today, because of the snow, because we have lots of snow in the land of Connecticut, we're going to go through some basic crosses. And I'm going to show you guys on the smart board software how to do basic crosses. So if we take a look at the document, it says in pea plants, round seeds are dominant to wrinkled seeds. If a heterozygous plant is crossed with a plant with wrinkled seeds, what will be the observed phenotypic and genotypic ratios? Out of 10, how many will have wrinkled seeds? So the first step is to determine the genotypes of the plants that you're crossing. So heterozygous, we're going to use R, is big R, little r. And wrinkled is little r, little r. Since it's recessive, it has to be two little r's. Then we're going to place our gametes, as we call them, onto the Punnet square. And I'm trying as easy as I can to write this. It's not that difficult. Ooh, the R went crazy. That's a little r. And then little r, little r. There we go. Okay. Then you fill in the Punnet square as nicely as you can. Obviously, I am having some trouble here. There we go. Okay, so there's our Punnet square. Now it asks for the phenotypic ratios. When you're doing a phenotypic ratio, you always put homozygous dominant first. So if you take a look for phenotypic 0 or homozygous dominance, we write 0. Next, in the ratio, you do heterozygous, and 2 are heterozygous. You see this one here, and this one here, they're heterozygous. And then 2 are homozygous dominant. Homozygous recessive, I'm sorry. So there you go here. And that is our phenotypic ratio. Now, for our genotypic ratio, it's always the number of dominant to the number of recessive. These two right here, they show the dominant trait. So 2 show the dominant trait. And 2 show the recessive trait. These two right here. So for the genotype, so this is the, this is the genotypic ratio right here. Genotypic ratio. And this is the phenotypic ratio. I might have confused those, did them reverse. Genotype is whether they're homozygous recessive, homozygous dominant, or heterozygous. And then phenotypic is what they look like. Dominant comes first, recessive comes second. And in the genotypic ratio, we have homozygous dominant, heterozygous, and then homozygous recessive. Okay, now to answer the question, out of 10, how many will have wrinkled seeds? Well, there's 10 total. Okay, and you multiply that by the probability, using the Punnet square, that they'll have wrinkled seeds. Half of them are likely to have wrinkled seeds, so you multiply this by a half. And if you do that multiplication, you should find out that 5 have wrinkled seeds. We're going to now go to the next problem, which is similar. Okay, so heterozygous plant, once again, big R, little r. And we're crossing it with another heterozygous plant. Big R, little r. Then we're going to put, as I struggle to write, and you really need a mouse, if we put our lovely gametes, as we call these, or sperm and egg, onto our Punnet square. Alright, so now we're going to fill in our Punnet square, and I got a mouse. It's much easier to do this on a mouse, so I'm happier now. Yay! Alright. Filling in the Punnet square. You can make mistakes if you do this quickly, so be watch. Alright. So now we need to do the phenotypic ratio. So how many show the dominant trait? We have this one showing the dominant trait, and these two showing the dominant trait. So 3 show the dominant trait, and 1 shows the recessive trait. So that's our phenotypic ratio. Now for our genotypic ratio, 1 is completely dominant, or homozygous dominant. 2 are heterozygous. And then 1 is homozygous recessive. So that is our genotypic ratio. And it asks, out of 100, how many will have wrinkled seeds? Well, if we have a total of 100, And then we look at our Punnett square and see the percentage that are likely to have wrinkled seeds. If you take a look, the wrinkled seeds is this guy here, the only one that shows the recessive trait. So 1 out of 4. And hopefully you can do that 1 out of 4 times 100 in your head. 1 out of 4 is 25. So that is this problem. On to the last problem. So if a heterozygous plant, now you can start skipping steps, big R, little r, is crossed with a homozygous dominant plant. Like that. Now we fill in the Punnett square. R, little r, that's what I feel like saying. Big R, little r. Okay. Now for phenotypic, we'll see all 4 show the dominant trait. Why is that? No 2 little r's here, all big R, little r's. And 0 show the recessive trait. So 4 to 0 is our phenotypic ratio. For our genotypic ratio, 2 are homozygous dominant, 2 are heterozygous, and then 0 are homozygous recessive. And how many will have wrinkled seeds? Well, we see 0 little r's, and 0 times 10 is 0. So 0 will have wrinkled seeds. For these crosses, the first 2, it might be a good idea to memorize the ratios. That whenever you cross a heterozygous plant with a homozygous recessive plant, half are going to show the dominant trait, and half are going to show the recessive trait. That's usually a good idea to remember that. And then for this one, for B, when you cross 2 heterozygous plants, you always get a 3-to-1 ratio of dominant and recessive traits. Those are good to remember or memorize because they come up a lot. When you get to more complicated crosses, it's better to have it memorized than have to do these simple crosses again and again and again. On the next pages of your homework are other practice courses, other practice crosses. Some of them require you to work backwards. D is asking you to do a test cross. So if you go back to the PowerPoint that I sent you guys out on Monday, it will tell you how to do a test cross. But some of the questions that are coming up in the packet, I ask you to work backwards. I give you one parent and the children, and I ask you to predict what the father could be. So they're asking you to work backwards. All right, good luck.